How's it going, everyone? Hope you're doing well today. Thanks for visiting my webpage. My name is Michael Lathrop, and I'm going to do a quick little video on some topics from meteorology. First topic we're going to talk about today is the adiabatic cooling process. So, in a nutshell, what it is, the air parcels will rise as the temperature of the parcel cools until it's at the dew point. And at this point, the parcel becomes a water molecule, which will collapse and form into a cloud or condensation. So let's take a look at a diagram of what that actually is. So as sun heats the earth in the form of heat, these rays here, the Earth's heat begins to rise. The warm air rises. So we've got a warm air parcel right here that'll begin to rise as it gets warm. And here it is, getting warmer and rising. As it rises, there has a smaller amount of pressure around it, and this allows the parcel to expand. As it expands, it begins to cool. In order to expand, it uses up energy, losing heat, and causing it to cool. And this process continues as the air parcel gets higher and higher. Rising up, cooling, rising up, cooling. Eventually, it'll get to the point where this cooler air will begin to approach the dew point. And the dew point is the point of equilibrium, where it balances out and stops rising. And just before it gets to that point, there will begin to be some condensation forming. Once it reaches to the point of equilibrium, you'll have cloud formation, which you see here, these white, beautiful, fluffy clouds. So that's just one way that these clouds can be formed. So there's different types of airlifting. So what we just kind of talked about there would be known as a convective airlift. The Earth gets warm, it causes the air to rise all the way up until it forms a cloud. Well, what's another type of airlifting that can occur? Another type of airlift is called the frontal or convergence lift. And this takes place when two masses of air come together. In most cases, the two masses of air have different temperatures and moisture characteristics. However, one of the air masses is usually warm and moist, while the other is cold and dry. And what happens is this cold, dry air that's coming in will cause to be a leading edge, which forces the warm, moist air higher. And as we just learned from the adiabatic cooling process, is when warm air rises, it causes it to expand and cool rapidly, which will result in a saturation or formation of clouds. So I know you're wondering, what happens whenever this process continues on over and over and over again? Eventually, you begin to get a process of oversaturation, and that's when you get precipitation or rain. So let's talk about precipitation a little bit. Assuming that the temperatures outside are below freezing, once you reach this point of oversaturation inside the clouds, you're no longer at a point of the clouds being a vapor or a gas. It'll actually condense to form a liquid. And at that point, it begins to get too heavy, and the liquid will fall from the clouds in the form of raindrops, which you see here. So this little blonde-haired kid with the umbrella is getting wet with rain because this cloud is oversaturated and it's raining outside. If it's really cold outside, below freezing, what you have is snow. So in order for snow to form, ice crystals are forming up inside the cloud instead of the condensed raindrops. and that they remain ice crystals as they fall all the way down because the atmospheric temperature is below freezing. It has to remain below freezing all the way as it drops from the cloud to the ground in order for it to fall as snow. However, sometimes snow can hit a temperature inversion as it falls, causing it to melt, but then refreeze as a layer of cold air just before the Earth's surface hit, causing it to refreeze. The result would be ice pellets known as sleet. So it's falling down, it melts, turns into rain, and then it continues to fall down, hitting another cold pocket of air, freezing and turning to sleet. Another situation I'd like to talk about is hail. Hail can be formed from updrafts from thunderstorms. Rain droplets inside clouds can quickly lift to a higher altitude. When these raindrops quickly lift to a higher altitude, it causes a quick freeze of rain droplets. These rain droplets can collide together, and when they collide together, they can form large pieces of ice at this higher altitude, which eventually will get too heavy and fall back down to the earth in the form of large hailstones. Hopefully that'll kind of give you some information on meteorology, and look forward to videos to come.